Hello everyone, welcome to lecture number 1, heat and mass transfer. So we're gonna start with the mode of heat transfers, and there are majorly three modes of heat transfer. Number 1 is conduction, number second is convection, number third is radiation. So we're gonna understand and gonna deep dive into it in the all the mode of heat transfer. So let's start with first mode of heat transfer, which is conduction. What is conduction? Conduction is generally a mode of heat transfer which occurs in solid. Okay, so mode of heat transfer which occurs in solids. Okay, and why it occurs? The basic reason is second law of thermodynamics. Okay, which says basic reason is second law of thermodynamics. Okay, second law of thermodynamics. I'm not gonna in the detail of second law of thermodynamics. I will teach it in detail when I will teach thermodynamics. So I will let you know the simplest meaning what second law of thermodynamics says. It says heat is always going to transfer from higher temperature body to lower temperature body in natural conditions. Okay, so this is what second law of thermodynamics says, that heat is always going to transfer from higher temperature body to lower temperature body in a natural way. So this is the natural way of heat transfer. In a natural way, heat will never transfer from lower temperature to higher temperature. If we want to transfer heat from lower temperature to higher temperature, we need to provide some work. We need to do some external work. Okay, so we will understand it in detail in later lectures, in upcoming lectures. So let's move forward. Okay, so what is conduction? Conduction is a mode of heat transfer which generally occurs in solids. And why it happens? Because the natural law that heat is always going to transfer from higher temperature body to lower temperature bodies. Okay, so in solids, how heat transfer occurs? How? Okay, so let's understand. For example, I have this, suppose a metal block, okay, which is in contact with another metal block. So I'm making that another metal block with a different color. Okay, they are in contact here. Okay, suppose this metal block is having temperature of 100 degrees Celsius, and this metal block is having temperature of 30 degrees Celsius. Okay, so there is a temperature difference. Okay, most importantly, for transferring heat, the main cause is difference in the temperature. If there is no difference in the temperature, heat will not get transferred. If this block is having same temperature as this block, there is no heat transfer is gonna occur between them. Okay, so the main difference is the temperature difference. So if this is the case, heat is gonna transfer from this block to this block. Heat is gonna transfer from this block to this block. Okay, so this is the conduction. Now, why it is getting transferred? Like how it is getting transferred in solids? So the first reason is obviously the temperature difference. Because of temperature difference. Now, due to temperature difference, how heat is gonna transfer, how heat is getting transferred here. So the first reason is molecular lattice vibration. What is this? We will understand. Second, free electrons, oblique motion. So what are these two terms? What are these two terms by which heat is getting transferred in solids? So this is solid blocks, right? So these must be having atoms inside it, definitely, obviously, because everything is made up of atoms and molecules. Okay, let's zoom into it. This is the molecules inside this metal block, which is having almost no space for the movement. Okay, so the moment the temperature of this block, which is having 100 degrees Celsius of temperature, is rising, the energy of this molecule is rising. Okay, so they don't have any space to move. So what will do? They will vibrate. They will start vibrating. They will start vibrating. Okay, so in this vibration, they're gonna do what? They're gonna transfer heat from one molecule to another. They're gonna transfer heat from one molecule to another molecule. Okay, and second way is free electrons. Because it is metal, it is definitely having it is definitely having what? It is definitely having what? Free electrons. So by providing this heat, free electrons will get the kinetic energy, and they will start to go to the equilibrium energy conditions. So they will start to what? They will start moving inside this metal block, and they will carry this heat, and it will get transferred in this way. Okay, this is free electrons. So these are the two ways, okay, by which heat is gonna transfer. First is molecular lattice vibration. Second is free electron oblique motions. So this is all about conduction. Now understand what is thermal conductivity. Now understand what is thermal conductivity. Thermal conductivity. So what is thermal conductivity? In simple means, thermal conductivity is a thermophysical property of material which tells you that how easily it allows heat to transfer from it. Okay, so what is this? Thermophysical property of material. Okay. And what it tells you? It tells you how easily heat is gonna transfer from that material. Okay. Thermal conductivity tells you that how easily heat is gonna transfer, how easily the metal allowing the heat to get transferred from it. Okay. So it is thermal conductivity and the symbol is K. It is represented by K. Okay. So for example, let's take some example. Okay. The thermal conductivity of silver and the unit is watt per meter Kelvin. We will get into details later on that why this is the unit of thermal conductivity. So the thermal conductivity of silver is 2100 watt per meter Kelvin. The thermal conductivity of copper is 385 watt per meter Kelvin. And the thermal conductivity of steel is 30 watt per meter Kelvin. So silver is expensive, so we cannot use it in making wires for electricity. But here you can see that thermal conductivity of copper, thermal conductivity of copper is higher than the thermal conductivity of steel. Okay, that's why copper is a good conductor of heat. Okay, what does it mean? Copper allows heat to get transferred from it very easily. Okay, so it is getting transfer from the copper. So what does it mean? Less accumulation, less accumulation of heat. Okay, what does it mean by lack accumulation? Lack accumulation of heat means copper will not get easily heat up when heat is getting transferred from it. Okay, that's why we use in we use it in electrical wires. We use it in electrical wires because they are good conductor of heat. Okay, and some other important facts we need to understand. First is thermal conductivity of metals is always greater than thermal conductivity of non-metals. Okay. Second, thermal conductivity of metal is always greater than the thermal conductivity of alloy. Okay, these are some facts. Why it is like that, we will understand. Okay, so So what is, like, why is non-metals having less conductivity than metals? Why non-metals? Because if we talk about metals, they have free electrons. Okay. And other hand, non-metals, they don't have they don't have free electrons. Okay. Generally, non-metals don't have free electrons. Second reason is metals are generally crystalline structure. Okay. And non-metal are both. Like it can have crystalline and amorphous. Okay. What does it mean by crystalline and amorphous structure? Let's understand. For example, crystalline structure and amorphous. So in crystalline structure, molecules are arranged in a proper order. They don't have huge voids between them. And in amorphous molecular structure, molecules are not arranged in order and they having a huge void between them. Okay. So that's why metals are good conductor. Metals having good conductivity than non-metals. Okay. That's why metals having good conductivity than non-metals. Okay. So non-metals, non-metals can have both. Non-metals can have crystalline structure also. Non-metals can have amorphous structure also. Uh, let's take one example of crystalline structure of non-metals. I will write it here. So it is like a, for example, brick, diamond, diamond. Okay, and in amorphous is like rubber, plastic polymers, and other polymers. Okay. So these are the example of non-metals having both kind of molecular structure. Okay. Okay. So brick having a very less thermal conductivity. Okay. Glass wool is a great example. Glass wool. Okay. Glass wool is having a thermal conductivity of 0.075 watt per meter Kelvin. It is very less. Just compare with the thermal conductivity of copper, which is 385 watt per meter Kelvin. You can compare that how bad conductor of heat. Okay. It will absorb heat. It will not allow heat to get transfer from it. That's why it is somehow used uh, in kind of devices or products which we use in our daily life, like thermos. Thermos In thermos we use glass wool because it doesn't let transfer the heat easily. Heat is get transferred. It is not zero, but it is very less. 0.075 watt per meter Kelvin is very less. It means if you keep if you keep water, a very simple example, you have a you have a bottle. Okay. This is a copper bottle, and you have another bottle. Okay, and this is a copper bottle, and this is a bottle which is used glass wool in its boundary and made of like that. Okay, glass wool. If you keep hot water, if you keep hot water in both the bottles, if you fill up with it hot water, the copper is gonna transfer that heat into the environment very fast, very fast, and the water is gonna cool down very easily. But it will transfer from the glass wool thermos very slowly, very slowly. For example, it can cool down the water in 1 hour, and it can take even 5 hours from this thermos, which is having glass wool shield around it. So this is how thermal conductivity works. Okay, and another important mm, parameter, another important fact, which is the thermal conductivity of metals. Thermal conductivity of metals decreases. It reduces when temperature rises at certain temperatures. Why? Because at certain temperature the lattice vibrations would be so fast. Lattice vibrations so fast. And what will happen because of that? Because of that, free electrons movement will be obstructed. Okay, free electron movement will be obstructed because of that. Okay, so that's why the moment temperature rises of metals, the thermal conductivity of metals reduces. Okay, second, in the non-metals. Okay, so if the temperature of non-metal rises, thermal conductivity, if temperature rises, thermal conductivity will also rise. Why? Because non-metals having large voids between the molecules, and lattice vibration increases. For example, non-metals having these large voids, these kind of voids they having. This is the voids in the non-metals, and due to lattice vibration, what happens is these voids reduces. These voids reduces due to lattice vibrations. Why? Because molecule starts moving. So these voids reduces and molecules interacts with each other, and they starts transferring the heat from one end to another end. So in metals, if temperature is rising, thermal conductivity is going to reduce. But in non-metals, if temperature is rising, thermal conductivity is gonna increase, especially in those ones which is having amorphous molecular structures. Okay, so thank you for watching. I will continue this subject in next upcoming lectures. Thank you so much for watching. If you like the lecture, you can like the video, subscribe to the channel. Okay, thank you. Stay safe.